All right, we're given a global carbon emissions from 1760 to 2010, and there's some ordered pairs given, so let's see what we can do with this. Do global carbon emissions appear to follow a linear or an exponential pattern? Now remember that linear is a straight line. And I don't know about you, but that don't look very straight to me. Whereas exponential starts slow and then curves. Yeah, that looks exponential because it is simply not a straight line. Okay, oops, wrong button. Whoop, okay. What is the unit of time? Well, we look at this. We appear to be in chunks of years, and these dots appear to be in 10-year increments. So 10-year chunks, right? 1750, 1760, well, wait, that's 1760, 70, 80, 90, 1800, 10, 20, 30, 40, 1850. So we are dealing with 10-year chunks as our time frame. Compare the amount of carbon emissions from 2010, that's, I need a color, that's here, to that of 2000 using relative change. So this is new, this is old. And remember, relative change is new minus old divided by old. Okay, so I'm going to take 33,472.376, subtract the old, 24,689.911, divided by the old, 24,689.911. All right, that gives me a decimal approximation of 0.3557, which is 35.57%. That means from 2000 to 2010, the global emissions has increased 35.57%, right? That's our relative change. If the relative increase were to happen again from 10 to 20, predict the amount. Okay, so we're saying in 2010, we had 33,472.376. We want to multiply by the increase. Remember back in a different video, we talked about take 1 plus the percent increase. And we're just doing one time chunk, so our exponent would just be a 1, which is just saying we're going to take 33,472.376 and multiply by 1.3557. And when we do that, we get 45,378.5 millions of metric tons of CO2. There's my label there. So we're talking, the next dot up would be way up here. That's what this is saying. Okay, new graph. Cable subscriptions are steadily declining thanks to the rise of subscription streaming services like Hulu, Netflix, Amazon Prime, YouTube has something now. The number of millions of cable subscriptions for the last several years is in the graph below. What kind of model best approximates this data? Well, it's straight. So that makes this linear. And look, they give you the y equals mx plus b form already. So let's go ahead and interpret the meaning of the slope. Well, the slope is negative 1.5904 over 1. And remember, the numerator represents the y values. So the y values are millions of cable subscribers, and the denominator is years since 2010. So you can see that every year since 2010, the cable subscriptions decreased by 1.5904 million subscribers every year. That's what this down here means. Every year we decrease by 1.5904 million cable subscribers. Could we use this to predict the number of cable subscribers in 2030? No, that is too far outside the scope. Oops, spelled it wrong. Scope of the model. Too many things could happen between 2017 and 2030. Way too many things. And therefore, it's too far outside the scope to use it.